If you've bought a 170 amp hour Renogy battery and you're having trouble charging it to full, well, you're not alone. It seems like a lot of people have the same problem. My story is I bought 2 of these a year and a bit ago. They basically got so imbalanced to the point where they had about half their capacity. I've managed to come up with a way of getting these batteries to work fine because the cells are absolutely fine. They did send me out 2 fresh batteries. This is one of them. I'm going to take the top of this battery off and I'm going to show you what's going on inside. I'm going to install a balancer. I'm going to install a switch which will enable you to switch the balancer on and off. And then with the Benchtop power supply, I'm going to top balance the cells. Right, so to start with, we're going to need to get the lid off this thing. And I would say that's probably the hardest part of this process. The things you're going to need is a heat gun, a big screwdriver, a little screwdriver, hammer. Now, if you get this right, we're going to be able to get this top off without doing much damage and will enable us to put it back again at the end and no harm done, or not much harm done. If you get it wrong, you will crack the plastic, which I have done on one of my 2. So you have to use this, it softens the plastic. If you use it too much, you're going to melt it, which you don't want, so you have to be really careful. This is a 2000 watt one, full power. And we're just going to start off doing this first little area here. Right, start with a small screwdriver into the gap. And then what we want to do is get it up. That's starting to go. I'm going to give it a little blast. Okay, that's starting to come up. I'm going to heat a little bit further along here. This is not an easy process. It's starting to go in quite nicely now. I'm going to take the little one out. And what we want to do is actually force it down the length to open the seam. But if this is cold, it might crack. So let's just make sure this is warm. Right, so now that side's down, we're going to flip it over to the other side. So that is all 4 sides open. So I can now get my screwdriver in right to the top, like that, and tap it on here. Right, that's just opened one corner. So it just popped it open. So I'll work our way around, but that's a really good sign. They're not designed to be taken apart, that's for sure. Very tempting to just jam this up, and yeah, you might get it off, but you also bend the lip, and once you've done that, you never get it back again. There we go. It's open. Now, that is not fun. Don't try this if you're not happy to take the consequences of damaging the case. But equally, we can slot that back on now. Already you can see Now, it's not that bad. So this is our BMS here. The fix we're going for today does not require us to change the BMS. Now, while we're here, let's just have a quick look at what's going on with these cells. The front of the battery, cell 1, cell 2, cell 3, cell 4. Now, if I put a multimeter on between here and here, I'm going to measure the voltage of this one cell, cell 1. And what we're getting is 3.345 volts. 3.345, exactly the same. 3.345, exactly the same again. 3.475. Now, it might not sound like a lot, but that is a lot. And that difference causes this battery to only charge to 13.8 volts. After that, it cuts the charge, and that's a problem. So, how are we going to fix it? Well, first of all, we need to charge cell 1, 2, and 3 up to full. And then we're going to charge cell 4 up to full. But cell 4 is basically full already. So really all we're doing is charging cell 1, 2, and 3 up to the same level as cell 4. Now with a benchtop power supply like this, it's got constant voltage, constant current. We set this to 3.6, and what it's going to do is it's going to reduce the voltage down, same as in a bulk stage of charge. And then as it increases the state of charge of the cell resistance effectively increases, and that means it needs to supply more and more voltage up until it is actually providing 3.6 volts, 5 amps. Then it will go into absorption, which is really constant voltage mode. Then the current will gradually reduce, and it's reducing as the cell becomes higher state of charge. So as that gets to 100% state of charge, or 98 or whatever, it will be drawing almost no current. So in theory, you can't overcharge the cell if we do it like this. It balances fine at 3.6, and it does just give you a little bit of leeway of protection because this cell won't go anywhere near fully charged. Now this is on and set, and we can set the current up full. Voltage is 3.6. Now before you connect it, have a double take. Am I doing the plus and minus correctly? If you do it wrong, you're essentially making you're putting them in series, and the battery's gonna try and short circuit. The power supply will stop it because it's got a constant current, but it'll probably blow up or burn out. The negative is here. It's where the BMS attaches, back left. So I'm going to attach the negative. I need to attach both these poles so they're making really good contact. Then the positive, I'm going to attach it here in the middle, which will energize cell 1, only cell 1. So let's do it. So what's happened, we're in constant voltage mode, which is absorption. So that means that cell is pretty highly charged already. So it's stayed at 3.6 volts and it's just dropped down to 4.2 amps, which is good. It means it won't take too long. But we're still going to have to leave this hours. The first battery that I did this to, which was like a 1.5 years old, so cell 1, 2, and 3 took about 16 hours each. Cell 4 took about 1 hour. So that was how imbalanced they were. This is a brand new battery and it's not that bad, but you can hope that on you. So it's been about 2 hours and it is 3.593, which is pretty much charged. So I'm going to call that done. So we're taking it from cell 1 into cell 2. So let's attach the negative to cell 2, which is here, and then the positive. Cell 2 there. So that started charging. Let's move on to the next cell. Negative in this bottom right corner, positive here. Okay, so that's cell 3 done. I'd expect cell 4 to charge up very quickly. So unlike the others, this one is going straight to 2 amps. Right, so that's cell 4 now finished. It was so quick. Took about 15-20 minutes as opposed to like 2 hours plus for the others. So there we go. Now I'm going to disconnect this all and leave it till the morning. So it's the morning. I charged all the cells up to exactly the same amount. Last night I left it overnight to settle. Cell 1, 2 and 3 have all settled to like 3.53 volts roughly. Cell 4 is higher. It's 3.57. And it's been sitting for like 10 hours with nothing attached to it. All the cells were exactly the same. And already there's an imbalance. Okay, it's the next morning and I think I know what's going on. What we're finding here is the peculiarity with these cells that the state of charge and the voltage is not that related. I think what's happening is cell 4 has been charged up to a very high state at some point in the past, probably when I first charged this. So when we charged that to 3.6, it was already a higher state of charge than that, but we just weren't noticing that. So I charged them all up to 3.65 volts, which is theoretically what the maximum we should be charging them to, and then left them overnight to settle again. The difference is reducing the higher I charge them. So I think that is the issue. It ultimately still have a top balance issue. The BMS has been unplugged the whole time and it doesn't seem to have made any difference. So currently I'm of the view that the BMS isn't causing the balance because I'm not seeing any evidence of that. However, I think we're going to keep testing and see what happens. So my plan is just to plow ahead. We're going to install the balancer. We need a soldering iron. You're going to need some very thin wires to do the switch and the light. So here's the switch. Now, why do you need a switch? Well, if we don't have a switch, it means that the balancer is on all the time at all states of charge, that you really just want to turn this on when you want to balance the batteries. Charge them up to like nearly full, turn this on and leave them, let them do their thing, and then switch this off again. This is high temperature battery tape, some heat shrinks, and the little connectors for the switch. There's two things that we need to do to this balancer before we start. One is the run pin, which is just here. We need to desolder that and add 2 wires to it, and that will become the connections to the switch so we can turn it on and off. Now I'm also going to desolder the run LED, which is on the back. It's quite hard to desolder. It's not designed for you to remove it. You don't need to do it, so it's up to you if you want to bother with that, but I will show you how to do it and you can decide. You need about 25 centimeters of wire. We just need to check that there's no touching of those 2 wires there. So we can just check continuity using the multimeter. This thing weighs so much. Right, so now what we need to do is wire in the balancer cord in parallel with the BMS. Now, just a word of warning here. These wires, if you short them, will short the cells and will burn the wire out. You must never like chop all the way through, because you'll short it on the screwdriver. You'll get a massive arc. So we need to do one wire at a time. So B minus, and if looking at the connector with the little catch, it is the wire on the right. And if you're having doubts, just line it up with the BMS socket and it's labeled B minus. And also if you're having doubts, you know what, I am going to get rid of this cable tie, being very careful not to cut any wires, because now we can check that the wire goes to the right place as well. And remember our cells 1, 2, 3, 4, B minus here, cell 1 in the middle, cell 2, cell 3, cell 4. Cell 4 is attached to the main positive. B minus is attached to the BMS. And then it's 1, 2, 3. So on the balancer, it's the left wire is the B minus. We have minus is the black one, and then 1, 2, 3, 4. Cell 4 is the red wire. I'm going to cut them about here, okay? And that is a distance of about 10 centimeters. It's quite easy to just accidentally just let this wobble about, touch something it's not supposed to touch, and you're going to get a big spark. It's absolutely horrid. I have done it. I don't think it would damage the cells, but it would burn out these tiny wires. They're not capable of taking the current of a short. Don't forget to put your heat shrink wrap on before you begin. Right, so that's one done. All we're going to do now is do the B minus to B minus, the 1, which is the green one, to this white cell here, the yellow wire, which is cell 2, to this yellow wire, the white wire to cell 3, and we've already done the 4. There we go, switch. This is where I'm going to put the balancer on the wall there, and on the left and the right side is a metal plate, and those are the plus and minus of cell 1. So just as a bit of a precaution, I'm going to put some tape over those two connectors. Okay, VHP tape on the back. So the run we want to wire it to, doesn't matter which way round, the normally open, so that's the middle one, and then the other part of the run goes to the common, which is the one at the top here. Then the LED goes to the two side top pins, which are labelled 1 and 2. Now it is an LED, so possibly if we get this around the wrong way, it won't light up. So we'll plug it in. If it doesn't work, we'll try switching these ones around. So, moment of truth, let's plug this in. I hope we don't get sparks. that's the BMS plugged in, nothing bad happening. Let's plug the balancer in. Nothing bad happening. Now the run pin is not connected. So let's press it and see what happens. I can hear it whirring, but there's no LED. So, it might be because we've got these around the wrong way. Okay, let's try again. Still no LED. Worrying. Oh, so that's lit up. So this cell 4 is 3.602. Nothing appears to be, yeah, it's gone down. Cell 3 is 3.582. A little harder to take the voltage of that one now. 3.581. Well, that's just going up. So that appears to be working. 3.585. It should be going up as well. That seems to be working. It is balancing. We're going to leave that and see if it balances itself, and then we're going to put a charge on. Okay, so this is set to 14.5 volts. And that should give us a cell voltage of 3.625. And so we're still creeping up there. This is looking so good. They're all around 3.6 volts. Very, very close. Cell 4 is only 0.001 or maybe 0.002 volts higher. So it's looking really good. Right, I'm going to leave it like this, and hopefully it's going to balance, 100% balance. Right, I'll be back in a bit. Okay, it's been sat like this for half an hour now, not that long. The charger is on 14.5 volts, really low amps. I've been monitoring the 4 cells, and they're very, very similar now. Let me show you. So cell 1, 3.625. Cell 2 is 3.625. Cell 3 is 3.625. Cell 4 is 3.626. So 0.001 volt higher on cell 4. And the voltage of the whole pack is 14.49, it's basically 14.5 volts. There is absolutely no way I could have charged this battery up to 14.5 volts before I did all of this. And it's super balanced. So plan now is turn this all off, let it sit, probably overnight again, and see what happens. Right, it's the morning again. Last night, after I stopped recording, I left this to continue balancing. The balancer was on, no charge, and it just sat there for 3-4 hours. And all the cells are exactly the same to the third decimal place. It was like 3.590, I think, all of them. And so I turned the balancer off and then left it for the morning. I checked it first thing, and cell 4 was fractionally higher, which worried me, but it was a tiny bit. It was 0.005 volts higher than the others. I put the balancer back on and left it for a couple more hours, and they have once again settled to almost the same. I switched it off now. The light doesn't go off straight away for some reason. So I'll check the voltages right now. I haven't done any charging since you saw it being charged. So cell 4 is 3558. Cell 3 is 3558. Cell 2 is 3557. Cell 1 is 3558. So right now they're pretty much all the same. even if that over time it's going to go out of balance again, it's easy now to just charge it up, press the button, and it sorts itself out again. I do think people out there with these, rather than put them in the bin, this is the solution. But anyway, we're not finished. We need to tidy this up, close the case, and then screw it down again. I'm going to pop a cable tie on here. So before I close the case, I'm just going to check everything looks okay. Nothing is loose or touching. So I don't really plan to open this again. So I like to use these metal self-tapping screws because they have an actual drill bit on the end. And it literally drills through the plastic and there's no way it's going to crack. Now it's safe to screw through 2 centimeters from the end on both of the long sides. About halfway up the side, 2 centimeters in. Thanks for watching. Now, a lot of this video has been sped up and I haven't given you all the detail that I wanted to give you. It's just taken me about a week to do this battery and I've got about 10 hours worth of footage. So if I'd put everything in there, it would have been unwatchable. But if there's something that you really need to see or really need to know and you can't make it out in time lapse, write it in the comments. I'll make sure I check them regularly and help as much as I can. I popped some of the links to the actual bits and pieces that you need to do this down below. And if I've got anything wrong or if I've said something that's not clear or inaccurate, please pop it down in the comments. Let's make this a place for people in similar situations to come, get help, get advice and fix these batteries so we're not all putting them in the bin. Thanks for watching.